Yeah. Let me introduce myself. Myself, Sivaji Thota, the founder and CEO of Aaharya Technologies. And I welcome you all for the boiler efficiency free workshop. Uh, because I think you are very interested or very excited about the concept. So that is the reason you are all here. You can type my name in the Google. Okay. Just type my name in the Google. Okay, you will get my LinkedIn profile directly on the top. And if you click on here and you can connect me via this LinkedIn profile. Okay, this is my LinkedIn profile where you will get all the information related to my projects and as well as to related to the workshop, all details related to my company. Okay. And now coming to the today's topic. Today's topic is on boiler efficiency. Why I choose this topic as a workshop? Okay, there is a main reason behind it. Nowadays, okay, when the people are trying to, especially when the chemical engineers, okay, when they're trying to get a job, okay, for example, let's say the graduation is completed. Once the graduation is completed, they will get a job because of three reasons. Okay, the first thing is that if they got a campus placement, okay, mostly process engineering companies will not come for the campus placement. Mostly pharma companies will come for the campus placement, and it is a 90% true that the growth rate in the pharma industries are very less. Okay, the chances, opportunities for to grow and the package that you're getting is it's very less. And the second way they will get a job is, they had some seniors in some companies. Okay, because every university have some alumni. So if they have a good communication skills or if they had some good rapport with the seniors, okay, they will get a job. Okay, by the reference of them. So that is the second way of getting a job. And the third thing that people will do is that, okay, get examination or they or go look for some jobs in some job search engines or like this. So the most of the time the people are limited themselves to such a jobs like this. Okay, either to get in a campus placement or to get a job from the reference from the friend or from the senior. And the third thing is to searching and applying for the jobs. And when they're applying for these kind of jobs, okay, when you're applying for these kind of jobs, mostly the chances to get, I mean, if they follow first two method, the chances to get is very high because the campus placement, most of the time pharma companies will give a very less payment and they will do. And the second thing is that when you are having a friend and then when there is opening, the chances to get is very high. But have you ever heard that, okay, if you're a chemical engineer, okay, and trying to get a job in a process profile is a blessed to everyone. Okay, most of the time when you ask any chemical engineer what is your next target, then what the people will say, I'm trying to looking for the process role, I'm trying to looking for the job as a process engineer or design engineer. So the people will share the opinion like this. Okay, yeah, whether they are from the they are students or the graduates or the professionals, most of the time they are willing to be a process engineer. And when you are trying to enter, when you would like to be a process engineer, so there should be some topics that you should know very clearly. Okay, there are some basic topics like, okay, you should know about basic engineering package, detailed engineering, PFT, P&IDs, and you should know about some simulation softwares. And along with that, you should know about very, very important topics like boilers and cooling towers. Because the boilers and cooling towers for an industry is like a energy sources. Okay, the boiler is a place where the energy generation is happening, and cooling tower is a place where we're trying to where we are trying to eject the heat to the atmosphere. So these are the two places where the huge amount of energy consumption is happening. And understanding those two equipments like boilers, cooling towers, refrigeration system within a process plant, so those things plays a very, very important role. So that is the reason it's very important to learn about the boilers. Okay, where if you, for example, if you attend this kind of boiler, recently I tried to look at some I came to know about some boiler efficiency calculations workshop, and where they are charging more than 12,000 for an entry. Okay, for a single lecture on boiler efficiency they charge 12,000 only for the single lecture of boiler efficiency. So then I thought that as a skill enhancement program, we are conducting many programs. So we thought that conducting this boiler efficiency program will helpful for the students, and as well as we'd like to tell you about the different training programs that our company offering. So that's why we conducted this training program. Okay. Now in today's session, we are discussing this boiler efficiency session into three categories. Initially, we are going to discuss about a general boiler introduction. Okay, what is a boiler and what is a different kind of type of boilers, or what basically the boiler feed water system is. So we will discuss about some of the important things initially, and then we will enter into the indirect method, and then we will enter into the direct method, and then we are going for an indirect method. So like this total, we are going to divide this entire program as a 3 different parts, okay, in today's session. Now let's enter into the session. So don't write it on the screen. Okay, if somebody write it on the screen, I will remove them from the meeting. Okay, because on the screen I have to draw something. So when I draw something, don't write anything on the screen. Because when you write it, obviously I would know that who is writing, so I will remove them. Okay, so at the end they will not get a certificate of this particular one. Okay, let's start the session. First of all, somebody tell me what is boiler. Okay, just type in that what is a boiler. If I ask the question like what is a boiler, you may come across with a different kind of answers. Okay, somebody will explain that the boiler is a place where you are converting water into steam by using a combustion medium. You can frame your own words. Okay, so typically the boiler means is nothing but it's an equipment. Okay, boiler is an equipment where we are using heat to transfer water into its steam. Okay, because we would like to use it for the process industry. So we are converting water into a steam. Okay, especially when it comes to the steam boiler. Okay, or else you can call it that as a steam generator. Or else if you'd like to generate the hot water, then that's called as hot water generator. So most of the time, even hot water generators also called as a boilers. Okay, even if you would like to if you would like to increase the temperature of the water and generating hot water for the industrial purpose, so that is also considered as a boiler. So it's completely your choice. Okay, it's completely your choice that what will be the definition for you about the boilers. Okay, based on your experience and based on the things that you've seen around in the industry. So you please frame your own sentences that what is a boiler. Okay, and after completion of this session, okay, now as I told you, this session is going to be happen around 2 hours. Okay, so after completion of this 2 hours of session, you people can proudly write boiler efficiency calculations in your resume. Okay, having boiler efficiency calculations, cooling towers, basic engineering package, detailed engineering package, PFD, P&ID, heat and mass balances, PSV sizing, and has analysis. So when you are trying to, if you're a chemical engineer, if your resume is equipped with these kind of topics, and as well as if you have a knowledge, okay, just by writing something in the resume is not enough. You should have update with that knowledge. If you have such kind of list in your resume, and if you have a capability, then definitely the chances to be get placed in MNCs are very high, no matter whether they are professionals or student. So that's why at the end of the session, if you people can able to listen carefully and ask your doubts, and if you understand everything, then definitely you can write that boiler efficiency calculations in your resume. Okay, after this session, I'm going to give you the 2 PDFs, okay, in a WhatsApp group, or else I will mail you 2 PDFs and as well as the one Excel sheet which contains all the calculations and as well as the formulas and a certification. So all those things that I will provide. So listen carefully and stay in the class up to completion. Okay, at the end I will share you. Okay, everything is completed, I will share you the sheet, then you have to fill the form. Okay, after that we're not going to share you any certificate and all. Okay, now, so this is a general boiler certification thing. Okay, there is one thing that I've written from some of the books. As I told you, you can frame your own definition. Okay, so now what is an application of a boiler? Okay, where you are going to use a boiler. So just can somebody type in the chat box quickly? What is the use of a boiler? Steam generation. Where you are using? I mean, what is the application? Where you are using? In which plant? Which process plant that you are using? Power plants, pharma, Prasanna said power plants, and pharma, power plants, sulfuric acid, thermal power plant. So different people are saying something, and monopoly, thermal power plants, cement industry, steam generation. So no matter what is the industry, whenever there was a requirement, whenever there is a process heating is required, okay, there is a processing fluid, and you need a process heating is required for the particular equipment, then obviously we are going for that. Okay, let's say there is some equipment, you require some, okay, this is an equipment, and there is some process fluid is entering to that. Once the process fluid is entering to it, And obviously, in order to increase the temperature of the processing fluid, you require some medium. Okay. In the most of the time, in such cases, we are using steam. So definitely in any process industry, we require steam. But especially as somebody saying thermal power plants. Okay. In order to generate steam, in order to generate the electricity, captive power plants, co-generative power plants, food and pharma, and in all other in every chemical industry, there is a requirement of a steam. There is a requirement of a boiler. When there was a requirement of a boiler, and there is a huge power consumption is happening at the boiler feed pumps, and huge consumption is happening, huge power usage is happening at the boiler, it's a very, 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 very important to learn about boilers. So there everywhere we are using a boilers, not only in an industrial purpose, we are using for the domestic purpose also. And recently we supplied a boiler to a 5-star hotel, okay, in order to generate hot water for the dishes wash and as well as for the hand wash and other kind of purposes. We supplied a boiler, hot water generation boiler we supplied. And in a recent times in some Bajaj Finance or some showroom, I looked at a cooker, pressure cooker, where that is also manufactured under IBR guidelines also. So there may be chances where the boilers is related to the domestic and commercial as industrial purpose also. So learning about the boilers is a very important thing. Okay. Now, when you are talking about the boilers, okay, we are talking about water. Okay, we are talking about mainly we are talking about water. So why we are using water? What is the major reason to use water? Okay, for steam generation, for the processing application, for process heating application, most of the time we are using a steam. What is the reason to use a steam? Yeah, Veera said it's a cheap. Okay, the water is availability, it's available for a very cheap. So that's why the people are using. And Ranjish said the higher latent heat of evaporation, easily available. And Prasanna said easily available. Expansion happens 1600 times. Utility and expansion happens 1600. Cheap utility, renewable source, latent heat. Yes, different people are saying different high HTC for steam and high thermal conductivity for steam, and it's a universal solvent. Okay, latent heat. Need low temperature to become a vapor, safer. Okay, different people are saying different things, but most of the people are right. Okay, the first thing is that the availability of water, it's very cheap. Okay, the water is for very cheap. Okay, water is cheap. The water is cheap. And the second thing is that the water specific heat is very high. Okay, the amount of heat that water can carry is very high. The specific heat of the water is very high. That is the second reason. Specific heat of water is high. Okay, CP value is very high. Okay, and the third thing is that it is cheap and it is available. And when it comes to the third thing, the latent heat of evaporation is very high. Okay, in order to convert water to steam, okay, in order to convert water to steam or steam to water, the latent heat of evaporation is very high for the water. The latent heat is very high. Okay, latent heat is very high. And the final one, okay, the fourth one, as somebody said, it's a universal solvent. Okay, but actually we are not directly mixing with anyone. Here the water is non-reactive to the many of the materials. Okay, in industries, what are the materials that you're using? Mostly compared to other substances, other compounds, it is non-reactive. Okay, so this is another main reason. So these are the 4 reasons why you are using water. For example, let's say first thing, why you have to use water when it is cheap? Because it is reduce your operational cost. Because water is cheap and it is easily available. So that is the reason we can able to use it for the operation where the operational cost is less. That is the first thing. And the second thing is that the specific heat is very high. When the specific heat is very high, then it can able to transfer more amount of heat. Okay, for just for 1 degree temperature rise, it can able to give a more amount of heat. That is a specific heat is high. That is another reason. And the third thing is that the latent heat. If the latent heat of evaporation is high. Okay, if the latent heat of evaporation is high, for example, let's say you are using water. Okay, you are using water in a heat exchanger. Because its latent heat of evaporation is high, even after heat transfer is happening, it still can be liquid state. I mean, it still can be in a steam. It can be in a vapor state. For example, if the latent heat is less, so the steam is entered into the vapor condition, and if because it's losing its heat, and if it is converted as a liquid, then the designing of such two-phase equipments is a very difficult. So because of a latent heat is very high, it's take more time, or it's a hard to convert. It's a stage. Okay, converting steam to liquid or liquid to steam is very high. Okay, maybe it is a superheated or saturated vapor, or saturated super saturated vapor, superheated vapor. At the time, because of a latent heat is very high, the chances to get into the liquid is less. So the two-phase design is not required for the equipment. So that is the third thing. And because it's a non-toxic, non-reactant to the most of the substances that is available in the industry, and it is a very safe. Okay, even if you are, if some water is poured on your hand, okay, if you are directly touched with the water, if you have a direct interaction with the water, still there is no problem. So that is the reason we are using a water. Okay, but there is a one disadvantage. Okay, but there is a one disadvantage because of using a water. What is that? What is that reason? What is the reason? What is the disadvantage? Corrosion, 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 corrosive, corrosive, corrosion, corrosion, corrosion. Scaling. Yeah, scaling formation is happening. And yeah, the scaling formation is happening because if the water is not pure, and because water is getting vaporized, so obviously there is a scaling formation is there. And fouling, scaling, different kind of things, as everybody mentioned. But there is another very important thing that you need to keep in mind when you are talking about the boilers. All other things are there. All other things are there for everything, everything. No matter what you're using, so all the problems will come. This corrosion, and if you go for other material other than water, then it is higher corrosive, then it is higher fouling factor. Fouling factor is very high. So many things. But one thing that you need to keep in mind when you're talking about water is, let's say you have a water bottle with you. Okay, you have a water bottle. Okay, let's say this is a water bottle, and this water bottle contains, the volume of the water bottle is 1 liter. Okay, you can pour 1 liter of water in this. Okay, if the water volume of water bottle is 1 liter, obviously we can pour 1 liter of water in this. Okay, and now let's say it is a vapor liquid curve of the water. So now initially the water is in a subcooled zone. Okay, the water is in a subcooled zone, and from subcooled zone to it reaches up to saturated liquid condition. So after saturated liquid condition, it reaches to saturated vapor condition, and then superheated vapor. So this is the basic journey of a water when you try to give a heat. So now initially water is in liquid condition in a subcooled zone or in a saturated liquid condition. But the moment, okay, water converting from a saturated liquid to a saturated vapor at a particular same temperature and pressure, okay, at 1 bar gauge pressure, 120 to 129 degrees centigrade is a saturated temperature. At that time, the specific volume is very less. That means you can able to put 1 liter water in a 1 liter water bottle. But after that, the water is converted as a vapor, as a saturated vapor, okay, from saturated liquid to saturated vapor at the same temperature, taking latent heat. Then you require 8,000 times more volume. Okay, that means in order to put on now 1 liter water in a saturated vapor state, you required 80,000 water bottles. That means 800 times more volume that you can able to expect just by changing a 1 degree temperature. Okay, just by getting from the saturated liquid condition to saturated vapor condition, the volume is drastically increasing. So when there was a sudden change in the volume because of a lesser difference of a temperature, you can see the huge explosion. Okay, so that is the reason boiler is a place where it is converting from the water to the steam. So where there is a very huge specific volume change, very huge volume is required. So that is the reason when there is a design, okay, when you are designing a boiler, we are designing a boiler as not like a normal vessel, normal closed vessel, normal equipment. We are designing as a 5 cube vessel. Okay, so the designing of a boiler is a very difficult. Okay, there are many regulations to design a boiler. Because of this is a major reason. There is a huge change in the volume. 8,000 times is a huge change in the volume that you can able to observe in the water. So that is the reason the designing of a boiler is a little difficult. Okay. Now, coming to the further discussion. So here, this is a place where, as I told you, that we are talking about a different application. So there are, okay, there are a different kind of things that are available here. So heavy users, medium users, and light users. The heavy users are food, pharmaceuticals, oils, all the other, industrial level. And then when it comes to the medium user, HVAC system, cooking, and chilling, fermenting, treating, cleaning. So all these kind of things are medium users. And very light users are electronics, horticulture, and humidifying. So like this, you converted, you can divide it into three. So out of these three, so different things are there. Okay, heavy, medium, and loose. So after that, we discussed about why water, why you are using water. So high specific, we already discussed about these kind of things. And so the specific volume is a major reason, and boiler is act like a fired gunpowder. Okay, when there was a sudden change, that 1 liter volume is converting as 8,000 times more, then obviously it's like a fired gun. So the fired pressurized vessel design. So the vessel design comes under a category of fired pressurized vessel design. Okay. So in such category, you have to design. So that means a lot of regulations are there. Okay. Now coming to the, okay, what are the things that I explained till now, or are basics? Okay, very basic things related to boilers. Okay, once again, if you read any PDF, okay, I will share you one PDF. If you read that PDF, okay, you can able to get more knowledge related to that. Okay, there is a IBR regulations. What are these IBR regulations? If the boiler, okay, if the boiler is, if any enclosed volume, okay, if you're trying to heat water, or if you're trying to convert water into steam, or if there is enclosed vessel and you try to heat it, whenever the volume of that particular thing is greater than 22.75 liter, then that comes under IBR. So that boiler need to be designed as per the IBR regulations. Okay, there are many huge regulations there. If you go for a IBR, if you just type IBR regulation in internet, there are many standards will come. So based on all those standards that need to be designed. Okay, if the volume of an enclosed vessel crosses more than 22.75 liter, that is the one thing. Or else, when you're operating an equipment, when you're operating a steam engine, okay, something when you're water converting a steam, which is greater than 3.5 bar gauge, with a pressure more than 3.5 bar gauge, at the time also you have to go for a you have to go for a IBR regulations. Then need to be designed as a IBR regulation. Okay, that is the second thing. And the third thing is that if the steam piping, okay, whether when the steam is moving to a pipe, and if it is greater than, the piping is greater than 245 then at the time also we will use a boiler, as a IBR regulations. So if you just type IBR regulations in a Google, and there are the different standards will come. So these are the, like limits. Okay, if it is crosses, okay, if it is crosses, it is a nominal diameter. 250, 245 is a nominal diameter. Okay, if it is crosses these kind of things, so 22.75 liters, 3.5 bar gauge, and steam piping of 2.45 nominal, at that time we will use the IBR regulation. And I will share you a small PDF, okay, which is about introduction, which is about some IBR things, which will give you a very clear-cut idea about these kind of things. Okay. Okay, if any of these conditions meet, then definitely it need to be. Okay, it is not always matter that all three need to match. It is not like this. At least one of the thing. An enclosed vessel which is more than 22.75 liters, which you are trying to heat it, or a different, a smaller volume one, which is happening at the pressure of more than 3.5 bar, or the steam piping more than 245, and in all such cases we have to guide as per the IBR guidance. Okay. Now, so when you are talking about a boiler, okay, just now we talked about a boiler, we discussed about a boiler and all. So remember, boiler is not a single equipment. Like say when you say distillation column is like, there is a reflux drum, there is a reboiler, okay, there is a feed pump. So like this, the distillation column have a different equipments like this, different setup. Okay, like this boiler means it's not just a single equipment just to put it there. The boiler is a combo of a different kind of things. Okay, many things that are involved in the boiler combination. Okay, so like this here I'm mentioning like feed water system, steam system, fuel system, auxiliaries, like this. There are many things that are mentioned in a boiler, boiler means. Okay, so if you look at a boiler, I mean, generally, if you go for a general schematic diagram of a boiler, if you consider this is a boiler, what are the inputs for the boiler? Okay, as per your info, as per your knowledge, what can be the input for a boiler? If you consider that entire system, okay, the boiler, entire boiler system is a vertical box. What are the inputs or what are the outputs for the boiler, as per your opinion? What can be input or what can be output? Rajneesh said feed water plus fuel. Okay. Process steam or outputs. Manupali, Badri, Narayan. Treatment dosing chemicals. Okay. Okay, we will discuss one by one. I think you already know, but in order to type it or it takes some time, or in your imagination, it needs some time. Okay. So, but anyway, I will explain you one by one. So we have first of all, you require a fuel. Okay, you require a fuel. Fuel need to be entered and fuel need to be burned, and it need to give a heat. So the fuel is required as an inlet. That is the first thing. And the second thing is that you need to give a water. Once the fuel is getting, giving a heat, who is need to observe the heat? The water need to observe the heat. So we require a water. And without, just by sending a fuel, it is not going to give you the result. Okay, it is going to, it is, we required air supply also. Okay, we required, we required fuel. Okay, we required fuel. You required air. Okay, you required water. So these are the things that are required. Okay, and when you're giving all these things as inlet, what are the things that are coming as out? We are getting a steam as an outlet, because that is a major product for us. Okay, that is a steam. Okay, we require a steam, and obviously because there is a burning process, you can expect some flue gases. Okay, there is an expectation of some flue gases that is there, and because it's a we don't know that what kind of fuel that you're using, whether you're using a solid fuel, gaseous fluid, or liquid fuel, you don't know. So that is the reason, obviously, there is some ash formation will be there. That ash can be coming out of it. Okay, and along with that, if you are giving a water, so water is getting evaporated. Once the water is getting evaporated, the TDS is in the water is getting increases. Okay, the dissolved salts, the everything is getting increased in the concentration of a boiler. So because of that reason, you need to give the blow down option. Okay, there is a blow down option is there. So we need to go for a blow down. Okay, when you're going for a blow down, so again there is a option of makeup water to the boiler that you can add, or you can ignore that. So like this, we have a different inlets and as well as a different outlet to the boiler. Okay, inlets of a fuel, inlets of air, inlets of a water, and outlet of a steam, outlet of a flue gas, effluent gas, outlet of a blow down, or outlet of a ash. Okay, now this is the situation. Okay, just look at the different kind of things which are entering to the system. First of all, fuel. Okay, we are having a fuel. Talk about a fuel. So there are three kind of fuels. Okay, that solid fuel or gases or liquid fuel. For example, when it comes to the fuel, how you have to think. Let's say we have a coal particle. Okay, we have a coal particle. If you have a coal particle and if you're burning it, you required oxygen from the atmosphere. Okay, from the different directions, oxygen need to become, and oxygen need to be supplied, and then it is burning. So after formation, after some amount of, after certain burning, okay, after it was burned, what will happen? After burning, so some amount of energy released, and as well as there will be a formation of ash. So whatever the formation of ash that was formed here, now this ash is not allowing oxygen, atmospheric oxygen, to reach the surface for the further process. So what is happening? Because of a burning process, whatever the ash that was formed, it is not allowing oxygen to reach inner surface. Because of that reason, there is a reduction, or there is a chances of reduction in the combustion. So here that ash is acting as a mass transfer resistance. So when you're giving a a solid fuel as a solid fuel as an inlet to the boiler, then these may be chances that formation of ash or formation of other product acting as a mass transfer resistance to the oxygen. So because of the reason, there is a efficiency regulations will be there in the feed, in the fuel. So that's why there are a different kind of system like pulverization unit. And in order to remove the ash, there is a very huge velocity air is entering. So there are many things. So there's a separate learning is there related to different kind of fuel systems to the boiler. Okay, that you need to learn. So there are some of the mostly the mechanical equipments are designed like pulverization and the stock kind of inlet, fluid bed catalytic feeding for the boiler. So many things related to the mechanical departments are available. If you're interested, you can type that different kind of boiler feeding, fuel feeding systems. You can get many information. Okay, but you need to think based on the what kind of constraints. If you look at the solid fuel, these are the constraints. What are the things which are forming is affecting for the combustion further? So that is one thing. So for example, if you are having a liquid fuel, okay, then there is another problem of the formation of other carbon dioxide, carbon monoxide. Again, is not allowing oxygen. If you are having a gas, so each and everything has a different kind of problem. That is about a fuel. And now, when it comes to the water, okay, when it comes to the water, the boiler feed water, okay, the boiler feed water need to have a particular quality. Okay, it should meet certain requirements. Okay, you should not have a dissolved gases. You should not have a other kind of salts like magnesium, other calcium. So you should not have such kind of salts, because if the water is too much dirty, okay, if the water is too much dirty, for example, if this is a boiler, the water which is entering to the boiler is too much of dirty and having too much of pollutants, it is going to scale up the tube, boiler tubes. It is going to rupture the entire tube of a boiler. So there is a very huge maintenance required, and as well as the damage will happen, which is again cost for the huge amount of capital cost for the industry. So that's why whatever the boiler feed water that we have, that boiler feed water should have a previous pre-treatment, like RO plants, okay, based on your requirement. Okay, based on the demineralizing water, you require a demineralized water. So you need to pre-process the water. So whenever there is a water, that water initially need to pre-process. Okay, there should be a pre-processing unit for the boiler water which is entering. Okay, so after water pre-processed, okay, the water was clear and water was pre-processed, then what you have to do is that whatever the water which is coming out of it, okay, which is very well cleared, that water that need to go for a water tank. Okay, whatever the feed water that we have, which is purified, that need to go for a feed water tank. Okay, water need to go for a feed water tank. Once water going for a feed water tank, let's say, what is the duty of a boiler? The duty of a boiler is converting water into steam. Okay, for example, let's say the water is at 25 degrees centigrade and you're trying to convert that as a steam, and water is at 35 degrees centigrade, you're trying to convert that as a steam. Water is at 45 degrees centigrade, you're trying to convert that as a steam. So when you're doing all these kind of things, which is a very easy one to convert? Okay, obviously the third one. That means when you can able to give her the higher temperature, okay, if you can able to increase the feed water temperature, obviously, okay, if you can able to increase feed water temperature, obviously that is useful for the boilers. Okay, that is reduces the energy. So whenever there is a possibility, try to increase the boiler feed water temperature. Okay, now we are sending the pre-processed water to the feed water tank. So after that, in a process industry, okay, in a process industry, somewhere in the process industry, already the steam is used. Okay, already the steam is used. We are having a steam condensates. Okay, maybe you are having a steam condensate at 90 degrees centigrade or 95 degrees centigrade or 98 degrees centigrade. Somewhere we are having some steam condensate, because already steam is used. Then it is converted as some high grade heating water, 95, 90 something like this. There may be some low grade of heat is also, steam is also available. So there is unused heat and unused steam is there from the process industry somewhere. Okay, so what you're using, that is coming from somewhere, and where I would like to utilize for the preheating of where I am utilizing this for the preheating of preheating of my feed water. So somewhere in a process industry, there is some water, okay, which is not, which is in some higher temperature. So I would like to utilize that one for the process of preheating. So after the preheating, so this is also water. This is, you know, the steam condensate is also very purified, okay, which is already pre-processed and entered into the boiler and converted as a steam. And again, it was converted as a liquid. So that is a very, very pure form, the very pure condensate. We should not use for the other purposes. Again, you require a boiler feed water. So again, whatever the condensate which is coming from other things, what is the less vapor stream that you're having, that need to, okay, that need to send back to the feed water tank by using some sparger. Okay, here we are using some steam sparger, where the steam sparger helping for the sudden drastic changes in a temperature and helping to dissolve if there is any vapors also in this particular integration. So the condensate which is coming is helping to preheat the feed water, and then again the condensate, the pure condensate is sending back by using a sparger to the water. Okay, water feed water tank. Okay. Okay. And then, okay, after using this, okay, after we are using this one, okay, if you should maintain a proper level, okay, within a feed water tank, because the continuously there was a from feed water tank to boiler feed water is going, so there is some backup water is there. Then we need to maintain a level. So there is a level controller on the top. That level control, whenever there is a reduction, automatically, okay, the water is coming, the backup water is getting added to the feed water tank. So after that, from the feed water tank, okay, we need to send the water to the tank by using some pump. Okay, that pump is called as a boiler feed water pump. Okay, by using this pump, we are sending to the boiler. Okay, if you're sending this to the boilers are operating at a very high pressure. Okay, the boilers are operating at very high pressure. So in order to send this liquid to this this feed water to the boiler, we require a very huge pressure. So that's why there is a very huge multi-stage pumping system is there. Okay, like we are putting different centrifugal pumps in a series in a multi-stage in order to reach that requirement. So like this, there was a feed water system with the entire energy integration option is there. Okay, and when you are talking about this feed water, we need to maintain the feed water at a particular height, because if you don't maintain feed water at a particular height, so because it is the hot water, okay, the feed water is a hot water. The different kind of things is there. Okay, water at 90 degrees centigrade, water at 80 degrees centigrade, and there's a different temperature regulations are there in a water tank, feed water tank. If there is a chance, at any chance, if the pressure in a tank reaches lesser than the vapor pressure, then the steam will generate. And if the steam is enter into the suction of a pump, and after that there is a huge pressure increase, and again it will convert as a water. So because of these phase changing that are happening, okay, at the suction and as well as at the outlet, because of that reason, there is a huge vibration that can be happen in a centrifugal pump. There is a chances of cavitation. So to avoid such kind of cavitation, to avoid such kind of scenario, we need to maintain the boiler feed water tank at a particular height. So the boiler feed water system is one of the energy integrated system. Okay, when if you can able to energy integrate from the other streams, this is a place where more and more amount of energy can be saved. So the learning about boiler feed water system and can able to draw this kind of schematic diagrams in an interview. So would be helpful for you to get into crack the interview. Okay. So this is the thing that you need to keep in mind. Steam condensate will not increase the TDS of a feed water, because the steam condensate itself a very clean water. Okay, it's a very purified. Steam condensates are very purified within the process industry. Okay, now see there is some ground rules are there. Like if you use 86 degrees, if the feed water temperature is 86 degrees centigrade, then the height is required is 1.5. If it is 90, 2.1. If it is 95, 3.5. If it is 100, 5.2. Like this, you need to maintain height in terms of meter from the ground. Okay, this is the feed water tank heights. Okay, like this, there is other things like boiler feed drum. Sorry, DRA tanks also there. So we will discuss. We know we are not going to discuss about such kind of part, but boiler feed drum is a boiler feed water system is a very important, okay, which we need to learn about, some schematic diagram that you need to understand, because most amount of energy integration that you are going to use at the boiler feed water system, okay, and you understand about the basic things related to boiler also, okay. Now, till now, if anybody had a doubts, that they can ask in the chat box. Okay, the pH. Okay, there is a pH temperature curve is yesterday. Based on the temperature of water that is available, so there is a pH, there is a small slight pH differences. Data is also available. That I will share that data. Okay, so that will helpful for you to gain about more about this pH and what is the TDS values which are available. So if you look at those numbers once, then that will give you the better understanding. I will share about those kind of things. Okay, and the feed water height. Why the feed water height is required? Okay, for example, if there is a feed water, okay, and if it is and this is a ground, okay. So obviously, okay, if you are by using some pump, if you are trying to send this pump to the a particular centrifugal pump or something, what is the pressure that is there at the bottom? The pressure at the bottom is it rho g h, rho into g into h. When there is a h is more, obviously the pressure at the suction will be high. If the pressure is suction at the not sufficient, for example, as I told you, because we are using a water at 90, 85 different degree temperatures, at any case, okay, at any case, if the pressure is lesser than vapor pressure, then automatically the liquid convert as a steam. When the steam is entering to the centrifugal pump, okay, because in this process when the steam is entering, and then after that, because of centrifugal pump, obviously the pressure will increase. So the steam is entering and it is converting as a steam in a liquid. Okay, the chances, even it is a very smaller amount also, because of lesser vapor pressure, it's entered into as a steam and then converting as a liquid. So there is a cavitation will happen. There is an empty space that is going to be happen. So that because of the cavitation, the vibration, the mechanical damage of a pumps will happen. So that is the reason we need to maintain a proper height. Okay. So that is also maintaining a proper height is the very important for the boiler efficiency. Okay. Now, look, these are the basic things. Okay, just need to, because before starting the meeting, I got some messages that, okay, please give me some intro, because I'm completely new to the boiler. Okay, like this, I get 10 messages or something. So that is the reason I just give some brief introduction. But basically, in the boiler efficiency calculations, we directly enter into the what is the efficiency and how we are looking about the parameters. Okay. So here in this class, I am going to give you the brief idea, the important the idea, and as well as the format and then Excel sheet. You are not going to get everything. Okay, I will give you the sheets and everything for the people who are attended. Okay, I will give you the sheets and everything for the people. And once you, after listening the class, maybe next day or day after the other day, if you look at those values and if you look at the formulas and if you just read those PDFs, you will get a complete idea. Okay. So now we will move on to the boiler efficiency calculations. Okay. So look at this one, all other things. Okay. All other doubts or you have all the other things that you have. So you will get those will solve in the PDF itself. Okay, the PDF is given by the Bureau of Energy Integration, India. So which is a very valid PDF, very authenticated PDF with a very bullet points, which every chemical engineer should read. I will share you that. Now, what is efficiency? Okay, somebody please tell me what is efficiency in the chat box. Yeah, somebody said it's output by input, actual divided by maximum, output divided by input into 100. Okay. Yeah. So now, as per your opinion, okay, as per your opinion, what is the input? Okay, when you're talking about energy integration, energy efficiency. So what is the input? What is the input of energy to the boiler? What is the input of energy to the boiler? See, I have a data to everything, like, boiler efficiency, cooling towers, Excel sheets, HVAC system, project drop, PSU sizing. So we are in the boiler efficiency calculation, and we are talking about this one. Okay. So look at here. I'm going to share this PDF with you all later. Okay, for the people who attend this particular session. So for anything, the efficiency is nothing but heat output divided by heat input into 100. Output divided by input into 100. So that is a basic. So now, what is the input and as well as what is the output to the boiler? Okay, what is the input and what is an output to the boiler? So let's talk about the inputs. We are having a fuel input. We are having an air input. We are having a water input. And we are having a steam outlet. We are having a flue gas outlet. We are having a blowdown. We are having an ash out. So like this, we are having different kind of things. So now, what is the heat input to the system? The amount of fuel, okay, which is burning, okay, the amount of energy that is giving is a heat input. Okay, that is the heat input. So, for example, 10 kg per hour is fuel is entering. Okay, 10 kg per hour is fuel is entering. So the 10 kg per hour of fuel into its gross calorific value, okay, is nothing but the amount of heat that you are giving. Okay, you are giving 10 kg per hour of fuel, let's say. So the 10 kg per hour of fuel into the gross calorific value is nothing but the amount of heat that you are giving. Okay, that is the input. And what is an output? Here you are getting flue gases, you are getting blowdown, you are getting ash. These are all not output. The major product for the boiler is a steam. That how much amount of heat it was, how much amount of heat that it was gained. Okay, initially we were having some water. After that, it's converted as a steam. So the gain, how much amount of heat it's gained is only the output. The thing that which is given from the fuel is input and this is the output. So now look at that here in the PDF. Sorry, just a minute. So look at here. Okay, that you can written as heat output divided by heat input into 100. Okay, heat output divided by heat input into 100. What is heat output? Heat output is nothing but heat in steam output. So what is the output that you are getting? You are getting steam. So the whatever the heat that is there in a steam, that is nothing but output, and heat in a fuel is nothing but input. Okay. So now, how you can able to write it? Okay, you can able to write it this. Okay, you can able to write it. For example, this is a system where we are having fuel input plus air, and where there is a steam outlet is coming and the flue gas is coming, and then we are giving a water inlet. Now, the energy is nothing but, okay, the amount of heat which is output is nothing but the energy added to the steam. The water is taking a heat and it's converting as a steam. So that means it is nothing but the energy added to the steam. So initially, water is at 35 degrees centigrade. And the water is at 35 degrees centigrade is taking heat and up to 120 degrees centigrade and converted as steam and leaving. So 120 degrees centigrade steam is having some heat minus 35 degrees centigrade water is having some heat is nothing but heat gain. Okay, the steam which you are having, okay, the steam which you are having is having a value of, okay, here it is having Q equal to MCP delta T. So this is having some dt. Okay, this is having some value. Okay, and here the water is also having some MCP delta T. Okay, Q equal to MCP. This is also having some delta T. So the difference between the output and input for the water. Okay, so this is how much it gained. So this is the heat it is taken from the system. So that is nothing but the output. That is the value that you're getting. So heat addition to the system. So that is added. See the steam flow rate. The steam flow rate is nothing but it's same. The volume, overall amount of volume, the mass is same, and the steam enthalpy and then water enthalpy. So that is the only thing. Then nothing but the fuel firing rate. As I told you, 10 kg per hour into the gross calorific value into 100. So this is the basic formula. Okay? The basic formula for the boiler efficiency is a direct method. Okay, it is just a direct method. For example, if I just a minute. Just a minute. Yeah. So look at this Excel sheet. So it is a direct calculation. For example, this is the general formula. You have the quantity of a water. You have so all the parameters that you have: gas calorific value, the fuel firing rate, and then enthalpy, enthalpy of water, enthalpy of, capital H is enthalpy of steam, small h is enthalpy of water, gas calorific value, and fuel firing rate. Okay, fuel firing rate and water firing rate. So water flow rate and fuel flow rate, gas calorific value of a fuel, specific enthalpy of a steam, specific enthalpy of water. So if you have this one and if you have these values, the boiler efficiency is coming as 72.5. Okay, the boiler efficiency is coming as a 72.5 for a general method. It's very easy, direct method. So now, what is the disadvantage of this particular direct method? Okay, in the direct method, directly we can calculate the efficiency of a boiler is 72.5. That is completely fine. If you can able to calculate as 72.5, but you cannot able to take any action. Okay, you cannot able to take any action against this. That means if it is 72.5, you don't know what will happen. Okay, you don't know what will happen if you increase. You don't know what to do to increase the efficiency. You don't know what to do from 72.5 to, if I would like to increase up to 80 or 73, 74, 75 or any number. If you would like to increase the efficiency, you don't know what to do. Okay, if you don't know what to do, then what is the use of finding out? Okay, you just find out. Okay, you just find out as 72.5, but you don't know how to change the things. So that is the here we comes here. So for example, in order to measure this one, we don't require much. You don't require water inlet temperature, steam outlet temperature, water inlet flow rate, steam flow rate, and you require what is the fuel flow rate and what is the GCG gas calorific value. If you have these values, you just find out, but you cannot able to change anything in the boiler efficiency. Just find out, but you don't know what is the how to do that, how you are going to affect it. Okay. Now, so that is the reason here there is a option of indirect calculation. Indirect boiler efficiency calculations are coming to the picture. I will give you the idea about indirect boiler efficiency calculations now. Okay, indirect calculations are very important. Now we are going to talk about that one. Okay, indirect boiler efficiency calculations. So what it is exactly? Okay, let's say we are having a boiler. As usual, what is inlet? Fuel is inlet, air is inlet, water is inlet, air, fuel, water. The outlet is the steam, flue gases, boiler feed water, blow down. And then we are having ash and ash or something like this. So like this, okay, we are having something like this. Let's say water is entering. Okay, water is entering. So obviously the firing is happening. So definitely there is a very huge amount of temperature, temperature in the boilers. Okay, because the fire burning, very huge temperature, like 300, 400 degrees centigrade. So very huge, incremental temperature. Now tell me, we are having a air. What is air? Air is nothing but oxygen plus nitrogen and some other inert gases. Okay, oxygen plus air. For example, if you are taking 100 kg mole of air. Okay, let's say I'm talking 100 kg mole of air. If I am taking 100 kg mole of air, okay, out of 100 kg mole of air, how much amount of air that I'm using really? I am using 27 kg of 21. Okay, 21 kg per hour of air, or 21 kg mole per hour, kilomole per hour. Okay, that means the air is containing both nitrogen and oxygen, but in the practical case, only oxygen is helping for the burning process. So the oxygen is getting burned, but remaining nitrogen, whatever the amount of nitrogen that we have, nitrogen, it is entering to the boiler and it is taking the heat and it's leaving. So that means what it is doing, the nitrogen, okay, the nitrogen storing the heat. So the nitrogen coming at a normal temperature of 35 degrees centigrade of a room as air, and it's entering to the boiler and it's taking a heat at 300 degrees centigrade and it's leaving. That means it's storing the heat. It's it's taking the heat. And for example, you are having a 100 kg mole here. Okay, 100 kg mole of air. Let's say that we are having a fuel of 30 kg mole per hour. Let's say that not 30, 15 kg mole per hour. 15 kg mole per hour. Okay, this is the fuel firing rate. Like say 15 kg mole per hour. If the 15 kg mole per hour is a fuel firing rate, for one mole of oxygen, for one mole of fuel, if you require 1 mole of oxygen, but you are having 21 moles of oxygen, but you require only 50 moles of oxygen, because 50 kg mole of oxygen, because 1 kg mole of fuel required 1 kg mole, for example. Okay, CH4 plus oxygen, that gives to CO2 plus H2. If that is the equation, 1 mole of oxygen required, 1 mole of 1 mole of methane required 1 mole of oxygen to burn. If in this case, for 50 kg mole of hour of fuel, you require 15 kg mole of oxygen, but you are having excess amount of oxygen. The excess amount of oxygen which is entering, which is coming to the boiler, and it's taking heat, and it's it's taking heat, and it's going out. Again, there is a loss. There is a loss because of a nitrogen. Now there is a loss because of an excess amount of oxygen. There is a 2 losses. And now let's say what are the fuel that we have. The quality of a fuel is not good. The fuel contains the moisture. If the fuel contains the moisture, whatever the moisture content which is there in the fuel is taking a heat, is converting as a steam, and escaping from the flue gases. Again, it's a loss. If there is a moisture content in the air, if moisture content in the air coming to the boiler, taking heat, and it is also removing. So the loss because of a nitrogen, loss because of excess amount of oxygen, loss because of a moisture in a fuel, and loss because of a moisture in the air. So these are all the 4. And along with the 4 losses, because of a blowdown, okay, when the blowdown is happening, what is happening? Because from the blowdown, the huge amount of heat. Okay, huge amount of heat is getting lost. Okay, we are losing huge amount of heat from the blowdown. So there is a loss because of that. And from the ash, there is a loss. And if there is a hydrogen, for example, if there is a hydrogen in the fuel, or if there is a undissolved, if there is for example, if there is a hydrogen in a fuel, again the hydrogen is reacting with the oxygen, excess amount of oxygen, and again it's forming as H2O, and H2 is escaping as a flue gas. So there is a very, very huge losses that are happening. Okay, if you study each and every loss, let's say, for example, you are having, let's consider the boiler efficiency is 100%. Okay, if the boiler efficiency is 100%, and if you're removing loss 1, and if you're removing loss 2, if you're removing loss 3, if you're removing loss 4, if you're removing loss 5. So like this, if you remove all losses from 100, that is nothing but a overall efficiency of a boiler. Okay, 100 minus the overall efficiency, 100%. Okay, 100% minus loss because of first case, loss because of a second reason, loss because of a third reason, loss because of a 4th reason, and loss because of 5 reason will give you the overall efficiency. And then you can have an estimated idea that what is my loss, where I'm getting more loss at 2, at 3, at 4, at 5. And you will exactly identify where I am losing more amount of heat. And once you know that where you are having a more amount of lose because of a heat, then you can identify, okay, then you can identify what is the place, okay, where is the place, what is the place where you can able to, what is the required things that you need to do in order to increase the boiler efficiency. Okay, so this is what the indirect analysis. Okay, we are not calculating directly, indirectly calculating what is the excess amount of oxygen that is there in the flue gases, what is the excess amount of unreacted fuel is there in the flue gases, what is the amount of ash, what is the blowdown loss, what is the loss because of a moisture. So like this, we are evaluating each and every parameter of a boiler, and you are going to find out the exact boiler efficiency. That is a indirect method. Okay, now we would like to look at the same in the PDF. Okay, now look at, this is the indirect method. Okay, so there are different losses. Okay, dry flue gas losses. Okay, what are the flue gas that you are having? So what are the gases, like, when the, let's say methane is burning, so obviously what will come? Carbon dioxide, hydrogen will form. So what are the reactant which is coming, what are the gas which is forming in the reaction is also taking a heat. So the dry gas is having a problem. And H2 loss, as I told you, if there is a presence of H2, So that is converted as a oxygen. So that is also here loss. And moisture in a fuel, moisture in air, and as well as CO loss. When CO will come? When there is a no proper combustion. When there is an incomplete combustion, then the CO will form. CO will form. That means the fuel is not burning properly. So that is also a loss. So that is a CO loss. And then fly ash loss. That means ash loss is nothing but when these flue gases are going out, there is some ash will come from the stack. So from that also there is a loss. And you can see from the bottom ash loss, obviously there is an ash which is coming. Okay, that is also having some loss. And then there is a blowdown loss. So 100 minus, okay, efficiency is nothing but 100 minus first loss, second loss, third loss, fourth loss, like this. All these things will come up with a indirect method. Okay, all this will come into the picture, and then they will be end up with a that is called as the indirect method. Okay, for now. And there is another loss called surface loss. Okay, because each and every body which is greater than 0 degrees centigrade is radiate. So there is a radiation loss is also there. If there is no proper insulation, obviously the convective loss are also there. So there is a loss. Okay, only this is not a loss. Only the steam output is not a loss. Remaining all the things is nothing but a loss most of the time. So you need to calculate each and everything, and you have to remove, subtract from the 100. That is nothing but a indirect calculation. Okay. Now, so here for each and everyone, we are for each and everything, we have a formula. So the defined formula. Okay. Let's say heat loss due to dry flue gases. Okay. For that, we have a formula MCP delta T divided by gross calorific value fuel into 100. So in order to find out the L1 loss, we have a formula. Okay. MCP delta T. Okay. Temperature of a fuel minus temperature of a air, ambient air, divided by GCP. So this is the formula. If you can able to know, okay, you need not to mug up the formula. Okay, you need not to mug up. Just need to understand what is the L1. That is because of a dry flue gases. So for the dry flue gases, this is the formula. So if you have, you need to just subject to the things, and you will get a loss because of a flue gas. Okay. So you need to get this kind of data. Okay. You need to know what is the temperature of a flue gas. So there you need to take all the parameters. You need to study all the parameters on the boiler. You have to ready with all the stuff, and then you need to go for a calculation. So this is the loss because of a H1. And then heat loss due to evaporation of water formed because of H2 in the fuel. If there is a H2 in the fuel, so there is a formation of H2O. And because of that loss, what is the loss? So here already they was calculated all the parameters, all the mole balances and all. Finally end up with a formula 9 into H2 into this 584 plus CP. So what they are doing, they are simplifying the formula. Okay, we simplify the formula, and this is the final formula for L2. Directly we can put a 9 into H2, all the values here. The data is there. That is you need to get all the data from the boiler. Okay, and then you need to enter this, and you will get a L2. So like this L3, like this L4, like this L5, like this L6, like this L7, L8. So like this, all the all the things will come 100 minus 1 plus 2 plus 3 plus 4 plus 5 plus 7. It is nothing but the overall indirect efficiency calculation, the overall calculation where you can like concentrate. If you are finding out that there is a huge loss because of radiation, what you will do? We will put the insulation. If there is a huge loss because of a excess amount of oxygen or excess amount of nitrogen, then you need to go for a oxygen suppression plant initially, and then you need to put it as a boiler. Only trying to get a more amount of oxygen. And make sure that you are sending a dry air. Make sure that you are sending a dry fuel. So like this, we are maintaining all the aspects, all the changes, and you try to get a better and better efficiency. Okay, so that's what we will do in a indirect calculation. Okay, and there was a small example is there, and I will share this entire PDF with you and this example, and along with this example, I will share you this Excel sheet also for the people who attended the session, and for the people who not attended, and the people who are not stayed, and after that they message me also. I don't share anything. Okay, I will only these for the people. I will share you this indirect calculation, and then the direct calculations one, like L1 loss, L2 loss, L3 loss, L4 loss. So like this, these losses are there, and this formulas also there. Okay, just need to enter the a little. I mean, you already know the formula inputting now as a chemical engineer. So if the small mistakes also there, I mean, we didn't enter the data at this moment. If you enter this data, obviously you will get a results here. So this is the direct calculation and indirect calculation. and the formulas and all. Okay. This is how we need to talk about a boiler efficiency calculations. Okay. Just go through the PDFs. Okay. I will share after this one. Okay. Any comments on this till now? Okay. Like this. Okay. So actually, what are the things that I mentioned is one of the class that we are that you're doing for now our training program. So Aaharya Technologies is doing everything as a skill enhancement program. Here we are having a mini diploma program in process engineering. Okay, Aaharya Technology is offering a mini diploma in process engineering. In a mini diploma in process engineering, starting from basic engineering package. Okay, starting from basic engineering package to we are having everything. Okay, distillation column design, reactor design, line sizing, wall selection, cost estimation, distillation column sizing, body of process engineering, design basis, design criteria, pumps, tanks, PFT, P&ID, using of vendor data, heat exchangers, boiler efficiency calculations, cooling towers part 2, and then pump calculations, tanks, and plant safety, plant commissioning, PSU sizing, HVSC, PFT and P&ID 10 hours lecture. Like this, we are having a full length training program on has been on mini diploma in process engineering. Okay, and for example, in the Google, okay, if you open Google and if you just type learn process engineering, okay, in the Google, if you type learn process engineering, our Aaharya Technologies site ranked in number 1. Okay, out of all other ads, these paid ads, Aaharya Technologies learn process engineering is the number 1 in India, not only in India, in the world. Okay, and this is our official website of learn process engineering. And if you look at this website, and you will get all the details related to course, instructors. Okay, look at this instructors. We are having 3 instructors: Sivaji, Thota, Pooja Malpan, and Prasant. And other than these 3 people, okay, other than these 3, we are having 2 other people also who are very much good at industrial experience and all. So like this, we are having a very well structured, very well planned training program for the graduates and students as well as the professionals. Okay, and basically we are offering this course. Okay, this course price is 22,999. Okay, in this 22,999 rupees course, you will get an entire course discussion, exercise files. For example, you are attending the class because of some technical reason you cannot able to attend, because of environmental reason you cannot able to attend. We are providing a recording classes. If you are working in a shifts also, we are providing recording classes, a certificate of completion, and advanced syllabus, interview, a sample interview test. Like this, if you join in training program, you will be equipped with a complete process engineering knowledge, and you can able to crack any kind of a job interview. Okay, such kind of syllabus that we design. And not only this, okay, and we are having a has-been assist training program also. Okay, other than this mini diploma, we are having the has-been assist training program also. In has-been assist training program, okay, I am pretty sure the people who don't have any knowledge in a simulation softwares, okay, people who don't have any knowledge in has-been assist, at the end of the training program, they can able to create their own plan. Okay, this entire has-been assist simulation program is there. So where the people, this completely, this entire has-been assist is taught by me only. So our technical team will install the software in your laptop for your learning purpose. And once the software is installed, then you will get access to all these videos. And then if you learn it, as I told you now, at the end of the training program, you can able to create your own plan. So like this, we are having 2 programs. One is mini diploma in process engineering, which is for 22,999 rupees. And another one is a has-been assist training program, which is 5,900 rupees. Okay. So like this, we are having 2 courses. And because this program is a very famous, many banks are giving EMI options also. If you have a credit card or if you have HDFC debit card, you will have a EMI options also. Okay, you can choose what are the plan you want, and like this, you can able to join this course. And the batch is starting from 15th. Okay, from this month 15th, we would like to start the batch. Okay, from this month 15th, we would like to start a batch for the professionals and as well as the students. And the classes are from 8:30 to 9:30 in the evening. Okay, every day for 1 hour in the evening times, we are going to give a sessions like 8:30 to 9:30 every day for 1 hour. 8:30 to 9:30, 8:30 to 9:30 next day, from Monday to Friday. Saturday, Sunday is a holiday. Like this, we designed a very well, process designing course for the students and as well as the professionals, starting from basic engineering to up to plant commissioning. That is for 22,999, and this aspirancy course for the 5,900 rupees. Okay. And for the people, okay, for the people who attended this boiler efficiency program, for the people, if they join before 14th, okay, 14th or 13th, okay, if they join in the next 2 or 3 days, they will get this aspirancy course for free for the mini diploma in process engineering. For the people who join in a mini diploma in process engineering, for those people, I can give you this entire aspirancy training program for free, including the software installation. Okay, you should have your own laptop. Okay, for the people who join in this mini diploma in process engineering program as early as possible, first 10 people, okay, the first 10 people who join in the mini diploma in process engineering, for these people, I will give you the aspirancy entire training program for free. And with the installation and with the lifetime access, I will give you access to all the videos for lifetime. So think about these kind of things, okay, because these are the training programs that you're offering. The mini diploma in process engineering for 22,999. Okay, you can pay via EMI options or your credit card options also. But I am sure, as you just now listen the class of boiler efficiency, so like this, each and every class is designed by the professionals having more than 15 years of experience. So definitely this course will, give you the very better understanding about each and every equipment. Your perception towards your jobs, your chemical engineering definitely will change. If you look at any job profile or anything in MNC, okay, you should have a boilers, has-been ICs, cooling towers, PFD, P&IDs, PSV sizing. So these are the things very, very much important. And learning all these things in such kind of live classes, in your part-time, in every time evening, within 45 days, you are equipped with all this knowledge. So that is the reason it's very important to attend this kind of course. And if you'd like to get all this kind of stuff like Aspen ICs, these training classes, live classes, if you look at now, obviously, other than Aaharya technologies, definitely it is cost more than 50,000. If you try any institute, as I told you, even the boiler efficiency workshop itself cost more than 10,000. So that's why, okay, you are getting, this is a very better opportunity for you to people to look at all this kind of stuff. Okay, I will share you all the information for you. Okay, once again, the people who are interested, they can join as early as possible to get a aspirancy completely for free for lifetime. Okay, now, anyway, thanks for understanding, joining this session. After some time, efficiency drops due to the following. How to calculate that? Okay, that was the internal factor of a boiler. Okay, fouling, and as well as any internal factors like there was a efficiency reduced in the burner. Okay, all the internal factors that are solved in the maintenance process. Okay, these are all not included, those internal factors. Okay, internal factors is a different thing. Okay, but those are going to be resolved in the maintenance. Okay, but these overall calculations is a different thing. It's a for the boiler. It's for the designed boiler. Okay, with all the good at its good working condition. This is the efficiency. In order to increase that, you have to take a certain certain other things. But what are the question that you asked is the maintenance issue of a boiler. Okay, now what I will do, I am going to share you the form. Okay, for the people who are attended today, I'm going to give you the certification for those people. So I am going to share you the form now in a chat box. Okay, and I will give you now 21:20 is there. Okay, it's what is the time? The time is 9:20. Okay, now I am giving you 10 minutes of time to fill the form. So the people who fill the form, for those people only, we are going to get a certification. Okay, let me share that file with you. Just a minute. I will share you all these files also. Okay, they're in a separate WhatsApp group or somewhere. I will share you. Don't worry. But for where is this? Yeah, I will share you this link. This link is not available or not accepted after this class also. Okay, now I shared the file, okay, form with you. Fill that form. Okay, fill that form, and once they fill the form, and you will get a certificate within 1 day or 2 days. Okay, based on my free time, I need to sign on the certificates, some digital signatures. So that's why. But remember, what are the training program that you are providing? That is definitely will helpful for each and everyone. Okay, So think about this program, and if you thought this would helpful for your friends or your juniors or somebody, for your students, I definitely inform them. Okay. Open this form. Okay, fill that form. Okay, I will share you the recording. If anybody had a doubts, okay, for example, if anybody had a doubt on a particular concept, okay, I will share you the entire recording. Now, whatever the recording that I have, everything was recorded. Okay, I will upload it and I will share it to you. Wherever you have a doubt, you just go through there. Okay, go through that. And whenever you have a doubt, you can reach me via mail. Okay, I will just send you my mail ID also, along with the whatever the certificate. When you get a certification, okay, you will get my mail ID also. Any doubts related to that, you can mail me on the mail, but the mail ID. So that is also fine. Okay, and I will share every detail and everything. Let's go through that mail. It's a 1.5 hour session. Actually, I am expecting this is to be 2 hours, but completed in 1.5 hour. No need to bother about mugging up the formulas. Okay, just to remember, I mean, what is the process? Why this is loss is coming? Why this is loss is coming? Okay, so once again, I'm repeating the losses. Remember, once you signed up now, just look at. Once again, I am talking about losses. What is that loss? Why you need to record that? Okay. Yeah. So the last one is because of dry flue gas. Dry flue gas is nothing but the reaction is happening. Okay, CH4 plus oxygen. The reaction is happening, producing carbon dioxide plus H2. We don't do anything. They are producing. They are forming. That is a gas coming out. That is a dry flue. Okay, that is a general thing which need to be coming out because of a reaction. So that is the loss because of dry flue gas, because that formation of carbon dioxide and hydrogen also having certain temperature and it's coming out. So that is the reason, that is a dry flue gas loss. So that is one thing. And the second thing is H2 loss. So because of having H2 in the fuel or H2 in the air or somewhere, because of this H2 is reacting with oxygen and forming H2O. So because of that reason, there is some H2 loss. Okay, the H2 loss means because of H2 there is a loss. Okay, and moisture in fluid. If there is a moisture, if there is a water content in the fuel, obviously the water converted as a vapor, and it's because it's having a more specific heat amount of heat, it is taking more heat and it's leaving not from the major main stream, it is leaving from the fuel stream, fuel stock. So that is also a loss. And then moisture in air, if there is moisture, if the air in the moisture is, that is also loss. And a CO loss, there is a carbon monoxide, so that is also a loss. Carbon monoxide means incomplete combustion. So when there is incomplete combustion, that means the burning is not happening properly. Then you have to check it at the burner and try to give a disvalorization, other kind of techniques in order to, as I told you initially, the thing which is forming is also acting as a mass transfer resistance. It is not helping oxygen to reach. If there is no sufficient oxygen, there is no proper formation of carbon dioxide. So then carbon monoxide will form, which is nothing but incomplete combustion, is a loss. Okay, like this. So these are the losses, and surface losses, and then the bottom ash loss. So these are the losses. Okay. So these are the things that you need to keep in mind. Very good, very important topic. So once you are clear about all this topic, write boiler efficiency calculation to resume. And in a training program, if you complete this training program, you can write boiler efficiency calculation, cooling towers, refrigeration, and you can write energy integration, cost estimation, basic engineering package, detailed engineering package, equipment sizing, line sizing, and the distillation column, reactors, heat exchangers. Like this, you can write entire thing, which is especially need for the process engineers or chemical engineers to grow up in their career. So definitely a wonderful training program will be, which is starting from 15th August. Sorry, 15th July. Okay. Have you filled this form? How many of you fill this form? Okay, type I will give a time up to 9:30. So after that, the acceptance will be closed. So please make it happen. Yeah. Prasanna filled the form. Okay. I read it like failed like this. Yeah. Okay, email ID will, I mean, when you are sharing a certificate now, when I am sharing a certificate now, it will, I mean, that will come from my official email ID for you. So at the time you can reply to that mail, and you can share this certification in your LinkedIn also. And by tagging my name like Sivaji Thota, you can share it also in the LinkedIn. Yeah, thank you everyone. And thank you for your professional behavior in the group. Okay. And this kind of interest is needed. Okay. So definitely all these sessions, okay, that Aaharya technology product definitely will helpful for you. Follow me for the future sessions and everything. Thank you so much. Yeah, people can leave. I will share you all the details. Okay, all the people who are interested for this training program, and I will share all the details. As I told you, that software is also completely for free for the first 10 people who are joined. Okay, so don't miss this opportunity. If you'd like to learn Aspen separately, that is again cost 20,000. So don't enter into that kind of corporate track. So this will helpful a lot. Okay. More than I have students in Saudi Arabia, Singapore, Malaysia. Even Malaysian university professors are my students. Okay, so definitely this course will helpful for you. Just have it try. Okay, this is all for today. And if still anybody not done, let me know. Okay, if anybody not done, if people who are done, just leave. Okay, once we can connect in a WhatsApp or in a mail, not an issue. The remaining people will stay. The people who didn't fill the form, I will take their names, and at the time when they contact me again, then there will not be any issue. Yeah. People who submitted the form, they can leave. The people who didn't, once again, I'm sharing in the form. Submit the form and leave. And anybody would like to message us, they can message us in a WhatsApp for the for joining of the courses and all. And I will just text you, okay, now from my message in the WhatsApp groups. Tomorrow or day after tomorrow, you will get a certificate.